Hey 7th graders, welcome to Chapter 3, Lesson 2. In this lesson what we're going to do is we're going to talk about ordering rational numbers. So we're going to compare them, tell which one's bigger or smaller, and then we're going to order them maybe from least to greatest or greatest to least. So we have two goals today. We need to be able to tell which rational number is larger. So this is where we're going to use inequality signs. So we're going to look back at some inequality signs that maybe we haven't seen in a while. Then we're going to be able to tell how to order rational numbers. Our standards for today, 7th grade number standard 2 and 7th grade equivalent expressions standard 3. Let's go ahead and start our lesson. For vocab today, we have 3 vocab words. We have rational number, and that's any number that can be written as a fraction. So whenever we write a decimal as a fraction, that's a rational number. We have common denominator. Common denominator is when we take a fraction, we make it so that the bottom, or the denominator, becomes the same. So common denominators are multiples of the bottom that makes the two answers the same. So if I had the fraction 1/3 and 1/4, they would have a common denominator of 12 because 3 will multiply to 12 and 4 will multiply by 12 to 12. Least common denominator, it's the smallest number that is a multiple of both denominators. So in this case, 12 is the least common denominator of 3 and 4. Now, I could make 3 and 4 have a common denominator of 24, 48, anything that they multiply to. But the least common one is the smallest number that both of those denominators will go to. So it's the first one that they make. Let's go ahead and look at our first example of comparing rational numbers. Alright guys, so we're going to be filling in the circle with either less than, greater than, or equal to. So what these mean is we need to understand what these mean. So we're going to fill in this and say whether or not this fraction is less than or equal to that fraction. Now, this symbol means less, or it means greater than. This symbol means less than. And this means that they are equal, which means the same. So what we have to do is we have to say, is this number bigger than this number? Is this number less than this number? Is this number equal to this number? So whatever number is on the left, that's what this sign actually represents. The number on the left is bigger than, the number on the left is less than, the number on the left is equal to. And we have to decide which statement works for this situation. So here we're looking at negative numbers as well as positive numbers, but in this case it's negative. So what we need to do is we need to think about a number line in this case. 0's here, -1 is here, and -2 is here. And we have to say which one of these is bigger. Well, we have a -1 and 5/6, and we have a -1 and 1/6. Now, a lot of people are going to say that this number is actually bigger. And in this case, that's actually a false statement. It's not actually bigger. Because if we look at this, -1 and 5/6. Well, here's -1, 1/6, 2/6, 3/6, 4/6, 5/6. So -1 and 5/6 is all the way back here. But -1 and 1/6 is all the way up here. Now, which one is bigger? In this case, since -1 and 1/6 is closer to 0, it's actually the bigger number. Now, since it's bigger, we're actually going to say that this number is less than this number. So, a good rule of thumb to understand which one's bigger and smaller is we used to go by the rule that Pac-Man eats the bigger number. So what we do is we continue this on, and we make it look like Pac-Man. Pac-Man's going to go ahead and eat the bigger number. So Pac-Man's going to eat the number on the right because the number on the right is bigger than the number on the left. So that's how we do this. We want to maybe sometimes draw a number line to be able to tell which one's bigger or smaller because we need to remember that as we go to the right on a number line, the numbers are getting bigger. In this case, to our first example, -1 and 1/6 is actually bigger than -1 and 5/6. Let's keep going. So in this example, we have to establish which is bigger, -3 and 3/8 or -3 and 7/8. So again, I might want to make a number line. So I'm going to go ahead and draw a number line. I'm going to have 0 here. Here's -1. is -2, -3, -4. And eighths means I want to split this up into 8 different pieces. So we got 1, 2, 3, 4, 5, 6, 7, 8. So if I want to do this, I want to establish which is bigger. Well, -3 and 3/8, 1, 2, 3, that's right here. -3 and 7/8, that's right here. So 7/8 is at the end. -3 and 3/8 is at the beginning. So again, I want to say which one's bigger. Well, in this case, I see that -3 and 3/8 is actually closer to 0, so that's the bigger number. So this number is bigger than the other number. So Pac-Man eats the bigger number, so Pac-Man's going to eat the number on the left. Alright, in example 3, we have to tell which fraction is bigger in this case. And in this case, we have 7 twelfths and 8 eighteenths. What we want to do is figure out which one's bigger. But they look like they're pretty close to each other, so it's a little harder to tell which one's actually bigger and which one's actually smaller. So what we want to do is we want to get to common denominators. Common denominators means we want to make the bottom number the same. So we look at 7 twelfths, and we only look at the bottom. We look at 12, and we look at multiples of 12. Well, 12 times 1 is 12. 12 times 2, that's 24. 12 times 3, that's 36. Then we have 48. Then we have 60, 72. Then we got 84. And then we got 96. So these are multiples of 12. Okay. Then we look at 18. And so if we're looking at 18, we got 18 times 1 is 18. 18 times 2, that's 36. I'm going to go ahead and stop, because I already see that there's a number that they're the same. We have the same number, 36 here and 36 there. So this means that I'm going to multiply the 18 by 2. So this 18, I'm going to go ahead and multiply that by 2. Well, 18 times 2 is 36. And if I multiply the denominator by 2, we also have to multiply the numerator by 2. 8 times 2, that's 16. So the fraction that we're comparing is 1636. Well, now we look at the 12. This is 12 times 1, 12 times 2, 12 times 3. So this 12 right here, I'm going to go ahead and multiply by 3. And if I multiply the 12 by 3, I got to multiply the 7 by 3. Well, 7 times 3, that equals 21. 3 times 12, that equals 36. So I see 2136, I see 1636, and which one's bigger? Hopefully you guys are seeing that 12 out of 36 is bigger than 16 out of 36. So in this case, the number on the left is bigger than the number on the right. And that's our answer to this problem. So sometimes we need to get common denominators. So we will look at multiplication facts of each number that's on the bottom and figure out where they meet first. When we find out where they meet first, that's called the least common denominator. I could take 12 times 18 and figure out another time that they're common, but that's a really big number. This is the least common denominator, and it's easy to tell which fraction is bigger or smaller than the other whenever we have common denominators. So let's go ahead and look at another problem. Alright, so example 4, we're going to compare these two fractions and figure out which one is bigger or smaller. So what we want to do is we want to find out multiples of the denominator and figure out where they're going to have something in common. Well, I'm looking at 4, I'm looking at 5, and I know 4 times 5 is 20. So 20 is a common number. I want to look and make sure that there's nothing smaller. And so I'm thinking about it. This goes 8, 12, 16, 20, 5, 10, 15, 20. So the first number that they're both the same is 20. So what we would do is we would change these fractions so that there's something out of 20. So we multiply 4 by 5, which gives us 20. We multiply 3 by 5, which gives us 15. So 3/4 is actually the fraction 15/20. Multiply this by 4, and we multiply the 4 by 4, so we get 16/20. So, which one's bigger, 3/4 or 4/5? And in this case, 16/20 is more than 15/20. So 4/5 has to be bigger than 3/4. And I know that Pac-Man eats the bigger number, so my answer would be something like this. 4/5 is bigger than 3/4. Okay. In example 5, we're going to be talking about roller shoes. And here it says, in Mr. Luft's class, 20% of the students own roller shoes. So if you've ever seen those shoes that have little wheels on the bottom, that's the type of shoes we're talking about. In Mr. McLaughlin's class, 5 out of 29 students own roller shoes. In which class does a greater fraction own roller shoes? So in this case, we're going to be comparing two fractions. Well, we know that Mr. Luft has 20%. Well, that's 20 out of 100. Because all percents are out of 100. So, Mr. Luft's class has 20 hundredths. Where Mr. McLaughlin's class has 5 out of 29. So, 5 out of 29. And what we want to do is we want to see which one has a bigger amount. So what we can do is we can change these fractions to decimals and then compare the decimals. So 20 out of 100 is the decimal 0.20 because it's 20 hundredths. And the 0 is in the hundredth spot. 5 out of 29 is about 0.1724. So if we were to compare these, we have to establish who has more. So this is 0.20, this is 0.1724, which is 1,724 10,000ths. So we have to say which one's bigger. What we could do is we could expand Mr. Luft out by adding zeros. So this is 2,000, this is 1724. Which one's bigger? The 2,000. So this tells me that Mr. Luft has a class that has more roller shoes than Mr. McLaughlin does. So we would say that 20% is greater than 5 out of 29. Because even if we were to change these to percentages, we'd move the decimal over, this is 20%, we'd move the decimal over, this is 17%. 20% is more than 17%. So out of these two, Mr. Luft wins. Alright, so in example 6, we have to order these numbers from least to greatest. So what we want to do is we want to change all the numbers to the same format so we can order them. That's the best way of doing this. Whenever you're given a set of numbers, it's always better to have everything the exact same type. So right now looking at this, everything's decimals, so it's easier to look at decimals and to be able to tell the order. So what I'm going to do is I'm going to expand decimals out to 3 spots. So 3.44 is really 3.44, and if I want to go one more decimal place, I can put a 0, because there's nothing behind it. Pi is the decimal 3.14, and then the next number would be a 1. This is 3.14, and if I want to put a number behind it, I could put a 0. And then the last number is 3.4, and since it has a line under it, or above it, it means that that 4 keeps going, so I'm going to put 2 more 4s. So, looking at this, it should be a lot easier to tell which decimal is bigger now that they all are expanded out to 3 decimal places. And the reason why we went to 3 decimal places is if we look at this, this is 3.4, this is 3.4, so it's hard to tell which is bigger, so we need to keep going so that way we can compare. We need to have about equal amounts. So 3.440, 3.141, 3.140, 3.44. And now we have to say which one's the smallest. So we look at these and say which one has the smallest number behind the decimal. Well, that's 140, this is 141, that's 440, and that's 444. So which one has the smallest number behind the decimal? That's this one. So if we're going to order these from least to greatest, the smallest number is 3.14. The next smallest is 3.141. which is just this symbol here. So we're going to put a pi symbol. Next one, 440 or 444, 440, so 3.44. And the final one, 3.4 with the bar above it. This is my numbers from smallest to greatest. So this is goal 2. In goal 1, we were able to compare 2 numbers. Now we're ordering numbers. So goal 1, compare. Goal 2, order. Let's go ahead and do another example. Alright, in example 7, we're going to order the set from least to greatest. So we're going to order these numbers from least to greatest. And this is the end of this video because it's the last part of our goal. So goal 2 is the ability to actually order numbers from smallest to largest. So what we need to do is we need to change all these to the same format. 7/10 is the decimal 0.7. 6/10 is already in its decimal form, 0.6. This says 0.72, and it has a bar above it, which means it keeps going. And this says 16 out of 25. And if you type that in your calculator, 16 out of 25 will give you 0.64. So now what we need to do is we want to expand these out one more spot. And if there's nothing behind it, the next number you want to put is a 0. So it should be easiest now to tell what the biggest is and what the smallest is, as long as we know our counting numbers. So do not worry about the 0. Look behind the decimal and then figure out which number is bigger. Smallest number, 64, 60, 70, 72. 60 is the smallest. So what we're going to do is we're going to write it back in its original form, 0.6. The next one, 0.70 or 64. 64 is the next smallest. So 16 out of 25 back in its original form, the fraction. Next one would be 7/10 because it's smaller than 72. So 0.72 with the line above 72. So if I had to write these from least to greatest, this is the way I would do this. That's it for today's lesson. In this lesson, you guys learn how to compare numbers, which one's bigger, which one's smaller, and then you guys learn how to order multiple sets of numbers. Remember, when ordering numbers, you want to change them so that they're all the same, but when you write your answer, you want to put them back in the original form, so that way we can tell that you understand what the question was asking. It's very important that you do that. You guys did awesome today, and I will see you tomorrow. Have a good day.